Where is it? There it is. Okay, so Gabriel, you'd asked me if I would just quickly go through this brief with you.
Perfect, thank you.
I'm not sure which parts I need to explain, but I'll go through it step by step, and then you can stop me when there's something that needs clarification. So basically, I'm wanting you to have a look at this extrusion here, which is something you can get off of GrabCAD. Okay, so you're going to take that extrusion and you're going to copy the face. So just do an edge. What is it called again? You're going to copy the edges of that piece and then copy that sketch, and then you're going to use that sketch as the basis for creating the parts that I want you to create. Does that make sense so far?
Yeah.
Okay, so in essence, what I'm asking you to do is what I've shown in these 4 illustrations, or maybe let's just go down. So it's essentially, let's see if I can zoom in. It's essentially an extrusion which is going to look like this. So it's similar to the one that you've got. It's just a bit simpler. And then another longer extrusion of about 1 meter, which looks like this long one here. And sorry, this zooming. And basically I want that round end to slide inside this round end or round depression in the 4-cornered extrusion, and then to be able to rotate from left to right by 50 degrees. So that you can...
So we're... Sorry.
Yeah, go.
We're designing the meter-long piece, right? And then the extrusion is the one that we get from GrabCAD.
No, you're designing them both.
Okay, then and then I'm confused as to which part we're getting from GrabCAD.
Well, you're going to use this. You're going to go and grab something like this. You don't have to. You can ignore it if you want. It's just easier, I thought, to go and grab an existing extrusion. It's almost the same size as what I'm looking for. It's got the basic arrangement. You can then use that to just grab a sketch off the end of this piece and use that sketch to create the sketch for this extrusion. Because extrusions are just basically flat sketches extruded. There's no modeling to them. They're just sketches which you extrude. Does that make? Do you understand what I'm getting at?
Yes, that makes a lot more sense. Thank you.
Okay.
So we can make them whatever shape we want to if we don't get them off GrabCAD.
Yeah, kind of, except I'm going to want this.
As long as it's like radially symmetrical.
Yeah, I'm going to want these. I'm
Like
going to want to do what I've asked for in these illustrations. So I don't know if you can see this first illustration here. I'm going to want these pieces to be able to be arranged in a kind of an acute angle arrangement, a 90-degree angle arrangement, a triangular arrangement in which you leave one of them out, or anything in between those 3.
Okay.
Okay, so I'm setting a bit of a challenge for you. Instead of just slotting extrusions into straight extrusion. Yeah.
So it's sort of like a hinge.
It's a hinge. Yep. It's a hinge.
Okay.
Yeah. But it's giving you options. And basically what this would have then is you'd have caps. You'd have injection molded caps or some sort of cap which you'd insert in this place, which would lock everything into place, top and bottom. And then you'd be able to insert your screen into these slots or those slots there. So I haven't visualized the whole system because I don't see why I should, and because I only want you to deal with those 2 pieces. That's it. And then obviously I want you to apply the tolerancing procedures that I outlined in my latest video. Okay. All right. We've got a whole lot more people here, which I didn't see. Who else is here? John, Johan, Jacques. Pleased to see you guys. Just mark you present quickly.
Hello, Phil.
Hi, who's that? I never can
That's
see.
Jacques.
Jacques. Hi, Jacques and Johan.
Hello.
Ah, and who's that? It sounds like
It's
Kyra.
Kyra.
How's it, Kyra?
All thanks. How are you?
No, I'm okay, thanks. Less stressed than you guys, apparently. And John. 1, 2, 3, 4,
Hello,
5,
yeah.
7. Who else? Who am I missing? Hi. Kutso. Oh, and Hamza, I've got you. Right, so that's great. Okay, so sorry, I just had to take register there. Any other questions about this brief? Got it, eh? Please give me your drawing files as PDFs. Please don't give them to me as drawing, as SLD, DRW, because then I don't have to worry about linking things, and if the file isn't there, I don't have to worry about that. So convert to PDF. I'm only going to accept PDF files. If you send me a solid drawing file, I'm going to give you 5% off. Okay. Right, can I close this window? We're not going to use it anymore. You can ask me questions through Signal anytime. Okay, so we're going to be dealing with the sheet metal today, and this is essentially what you're going to be designing for me for your last project. Next week is our last session together. So between this week and next week, I have to teach you everything that I can on sheet metal that's relevant to this project. So don't worry, we're not going to start with this. We're going to start with something simpler. Let me just maximize. Start file. New. Before I start, how much do you know about sheet metal? Any of you?
We did a relatively simple sheet metal project last year in Solidworks.
Okay.
And like we also had to make paper airplanes.
Paper aeroplanes. Okay. Okay. So I'm going to start from the beginning and just assume you guys can stop me if it's like too basic. Just stop me. So I'm going to start with a sketch on the top plane, and I'm going to try and keep this very, very simple in the beginning, just because it's going to get a bit more complicated as we go along. So I'm going to start just with a square. Let's make it 100 by 100, and then exit that. Okay, so this is the very most basic approach to sheet metal. There are other approaches. We'll go through them in a while. So I'm in my sheet metal tab, and you'll see across the top here that there's the base tab, which is what you always start with, unless you're doing something else, which I'll get to in a moment. And then the second one that you use is hidden at the moment. It's edge flange. So base flange, if you click on this tab, you'll get on the left hand side a number of options. One, you can use a gauge table. I'm not going to go through that now, but just to be aware that there are tables available. So if I click down here and I say bend allowance millimeter sample, it'll actually, you can set up your own table and you go and select your gauge from that. Gauge just means how thick the thing is. So gauge is one of those words which, like a 1 millimeter gauge, isn't actually 1 millimeter. It's 0.97 or something. So instead of using the gauge table, I'm going to type in, here it says the thickness, so I'm going to type in 1.1. You can reverse direction as always. And then these other things, K factor is, I'll explain it in another video, but it's essentially a kind of a way of figuring out how the bend is going to work. And then relief, you've got three kinds of relief: rectangular, tear, and OB round. I'm going to leave it at tear at the moment and say click OK. Right, so basically we've got a piece of sheet metal at the moment, just a very square one. From here we can put in edge. Basically it's going to be edge flanges. So this command over here, I've got it in a set of commands. I like to have it over here. I also like to put it, because I use it a lot, I like to put my commands in this pop-up. So I'm going to go to edge flange, and from here I can select as many edges as I want, and I can drag up. So once I've dragged one up, I can select another one, and another one, and another one, or I can leave one out. So you should be able to see here in this little tab at the left, you can right click and delete any one of those. So let's just leave it as 3 for now. Then a few things to know on the left hand side is, well, let's just go through these one by one. So here I've got this use default radius. Now the default radius normally follows the same as the thickness of the object. So if I've got a thickness of 1.1, you can see it's defaulted to 1.1. I can click on that button and I can say, no, I want that to be bigger or smaller. When you're manufacturing, you basically stick to the bend radius being the same as the metal thickness. But that is available to you. So I'm going to go back to 1.1. This is the gap distance. That's the distance between the two edge flanges. So I can make this bigger. So let's just make it bigger, and you'll see it grows. Let's make it 0.5 for now. And then the angle, I can alter this. Obviously, if I click on that, you can see they're angling in. Or I can type in, I can say I want them to angle out by 70 degrees. That's what they're going to do. So 90 degrees. Let's go back to that. Okay, so there's a lot you can control in this feature manager tab on the right. And then the length, that's just how high this is. So I can make that say 100, off it goes, or I can make it 30, whatever it is that I want. And then these 3 commands here, the outer virtual sharp, inner virtual sharp, and tangent bend, just tell you where that bend is going to start from. So if I zoom in here, you can see the bend is starting from what it's calling the outer virtual sharp. In other words, where that line there and that line there meet would be the virtual sharp, which it calculates as being half the thickness. So if I go to the inner virtual sharp, doesn't seem to have done anything. It will have an effect. Okay, and then the next one, I've got to figure that one out. The next one is the flange position. This will have an effect. So this will position the flange either right, sort of on the end, or inside, so that you can see that that face there is matching this face here, that little face there. So this is the standard one, which is, I forget what it's called, material outside. There's a kind of a ratio here. I think it's about half. I think what it is this inner face matches that outer face. And then here you can actually determine, well, that's like popping it onto the end of it, but you can also offset it. Well, in fact, you can offset it at any time. So if I want to offset it by, say, 1 millimeter, so 1 millimeter, you can see it's taken 1 millimeter and added it to that piece. So this is all useful to know, because this is going to help you in the way that you design things, because you're going to want to do something along the lines of all of these at one stage or another. Too complex to explain where you'd use them at the moment, but as long as you know that these could affect your design. And then the bend allowance that's the K-factor thing. So essentially this is a ratio between the center of the bend, or the center of the material, or the percentage of the center of the material. So 0.4 is like 40% in from that position, so about there. That's where you calculate the sort of the most neutral part of the bend. Because when you bend something, the outer bit of the bend stretches and the inner bit of the bend compresses. So don't worry about that too much. Leave it on 0.4. Different materials have got different K factors. And then the custom relief type is, there are 3 of them. There's a tear, an OB round, and a rectangle. So we'll have a look at each one of those. So I'm going to leave it on tear for now. Say OK. Right, and so let's have a look at what it's done with that tear. That's a tear. What happens there? That's representing what happens with a tear. And if I flatten this, so there's a command up here. There are 3 of these commands: unfold, fold, and flatten. Now, flatten is the one that you only use to visualize what's happening with your part. So if you push flatten, it'll flatten it out, and you can see whether everything's working. Okay, so let's see if we can make this thing not work. I don't know if I'll be able to get it right. Yes, I will. I'm just going to add a tab onto this piece. Not right. Okay, I'm not going to dimension that just because I just want to illustrate something. So you can add bits to your design at any time by just drawing a sketch on a face and then just extruding it. Sorry, not extruding it, but going to base flange, and it'll add it on. It'll actually merge the result. Say OK, and say OK. It should say, you see its tab features is crossing a bend. So it won't allow me to do it, because if I were to flatten this, I don't know if I can get this to actually just, I won't do it. So the reason I want to get this object to show an error is to show what happens at the bottom here, especially when we use the flatten command. The only way I could get get Solidworks to do this is to actually alter the sketch instead of adding a tab. So this is what I've done. I've added a little section onto the flange of 1.8 in this area. You can see there's an error message straight away. And the same I've done with, I won't go into it, but that one. So that now these 2 parts are intersecting, which is, obviously you can't bend something like that, so that's an error on its own. But also just have a look at what happens when you flatten. Flatten will show you, this is a glaring error, but it'll show you where the 2 parts are intersecting at the flattened stage. So in other words, there's no ways on earth that you could cut this thing, because you've got an intersecting diamond here of material, which is physically impossible. Right, so from here, let's just hop across. That's the basic method. Let's go to 2 other methods. So I'm going to go to, one way is to loft this a shape. So let's say you were doing some sort of ducting, and so what I've done here is I've created 2 sketches which are set apart by a certain distance. So just have a look at this sketch quickly. The sketch is not closed. It has an opening of 0.4 millimeters, and this sketch as well has an opening of 0.4 millimeters, and they're in the same place. I mean, you could put them in different places, but that's asking for trouble. So if you've got 2 sketches like this, you can use the Loft Bend command, which is over here. So you select the one and you select the other, and it lofts the bend for you. And you can control things like number of bends, for instance, segment length. I'm not going to get into all of those, but if you've got something complex like this, which can be done, then this is the way to do it. So if I were to flatten that, I think the reason it's taking long is because of the number of segments. So that's what it's going to do. Okay, and then just to be aware that if you did this, it would mean the manufacturer that you're going to use would have to make what are called step bends. So they'd have to make a bend, 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 a bend each time to get this thing to work, unless they had some sort of tool which they could bend the thing around. But in this one they wouldn't do that. So just be aware that if this is what you want to get done, this is going to cost a fortune because of the number of bends that are required. Each of these lines represents a small bend. So these are called step bends. Okay, so that's my flattened done.
I do have a question.
Sure, go for it. Go for it, Hamza, I'm listening.
I just wanted to ask if you're recording.
Oh, I'm recording, yes. Is that what you asked? Am I recording?
Yeah, because I like to use the video as reference when I am doing work related to this.
No, of course.
Then I just go back and check.
No, absolutely. No, that's what they're there for. That's what I like. I like this way of teaching very much because it means I don't have to go and repeat myself. You can just watch the video. Yeah, I'm recording. Don't worry. Okay, so that's the loft. For now, you're not going to use it, but just to be aware that it's obviously a major way of doing things. If you're doing complex shapes, which you need to loft. Okay, so I'm going to close that. Alright, and then one other way, well, there are a couple of other ways, but I'm only going to show you 3 basic ones. So you can start from a solid and use the solid as the basis for your sheet metal part. So I've just got a square base here, which is 100mm square, and I've tapered it up by 15 degrees to a certain height. Can't remember what it is. So you could start off with a shape like this. Just a word of caution, don't start with shapes with corners on them, like with radii. Don't put radii. It must be sharp edged. There are some instances where, like if you had a very large radius, you could do that, but the basic idea is that you have, obviously, depends on what you want to do, but you usually have sharp edges. So if I go into the sheet metal tab, you should be able to see, where is it? Convert to sheet metal. It's the second command. The first thing you need to do is to select the face that you want to keep. So you'll see along the side here, you can use sheet material metal parameters. You can use a gauge table again, and the first command that you need to, that sort of blues asks for is the base. So that's the piece that you want to be the starting point, and then everything else is going to be split according to that. So then the material thickness, or the sheet thickness, I've got 1.2. You can reverse thickness as always. You can keep the body. So let's say you want to keep this body to be used in another part, or you can discard it. And then the bend radius, which is the same in this case as the sheet metal. And then you've got to select the bend edges. So it's just these 4. And here you've got to visualize a little bit. You've got to figure out, well, sorry, it's not those 4, it's these ones here. Where are the bends going to occur? So they're going to be on these 4 corners, 1, 2, 3, and 4. And then you see it immediately rips the edges. It's called rip edges. So it immediately decides for you that since you're bending on that edge, it has to rip these 2 edges. It has to create a gap in those 2 edges. And you can use sketches to do the rips as well. I've never used that, so I'm not going to go there. And then at the bottom here, you can decide on what kind of overlap. So you can do an open butt, an overlap. I don't think we'll get a visualization here. No, it won't. And then you can decide on the gap. So at the moment, that's at 2mm. That's quite big. I'm going to make that a whole lot smaller. Let's make it 0.2. See what happens. And then there's an overlap here. Actually, let me see if I can make this give us an error. It might give us an error of 1mm. So once you've got all those things in place, and then obviously you can decide on your K factor as well. It's given me 0.5. I want 0.4. Right, it's done it. and it hasn't given us an error. Damn. Okay, so let's just flatten it to see what happens. So you can see it's flattened it. Alright, and you can see there's a little gap between those two, so if we were to measure that, that should be 0.2 between there and there. It is 0.2 millimeters. So let's just quickly look at what happens when we choose one of these other ones. Just have a look quickly at this auto relief. See if we put in an OB round, if it'll show us what the OB round does here. Not quite. Okay, but here you can see, it looks like we've already run out of time. Another 10 minutes to go. Oh, not too bad. Did someone ask a question? No. Okay, so you can see what happens when I do an overlap. And you can see here that these two don't meet nicely. I know there's a way that you can actually get them to meet nicely as well. I'm not going to go through it right now. I think that basically explains it. So you can see how big this opening is at the bottom. That you should be able to adjust. I'm going to let's go back to this one. Going to that ratio, I think that does it. Let's just make sure. No, it hasn't affected it. Okay, right. So I'll figure that one out and just do an edit and just explain those things that I haven't explained nicely here. Right, so those are the three basic methods. There are others. You can do things like put gussets in, which require tools. You can use forming tools as well. You can create your own forming tools. So that's like say putting a kind of like a raised bit in the middle, or even putting a pattern in. Forming tools are like press tools. So it's like an injection molding. You have a male and a female, and you press the piece of metal between the two, and it deforms it. But that basically is the three basic methods of creating the starting points for your sheet metal. All right, so I'm going to hop across to my router, which is this router here. I'm going to open this. Actually, while we've got just these few minutes left, I think I'm going to go back to this one here and show you something that I was promised to show you, which is configurations. So the configuration manager is this middle one. If you go to the feature manager tree, you'll see your feature manager on the left hand side, property manager where you can change properties, and then the third one is the configurations. And you'll see it starts off with a default configuration, which is you've always got a configuration. So the way this works is you can add a configuration, give it a name. So I'm just going to say Alt1 for now. And then if I go back to this part, let's just click on that. And I click on a dimension. You'll see the dimension leader on the left hand side. Just under the dimension you'll get configurations, and you can decide that the dimension you're going to set is going to apply to this configuration, which means the configuration you chose, Alt1, which is actually highlighted here, although it's not easy to see. Say OK. So I'm going to change that to 60 or 65. Say OK. Just update it. Okay, so you can see it's reduced the whole thing by 35 millimeters. And if I go across to the default one and I double click it, you'll see it enlarges it. So now it's back to 100. I'm not doing it. So that's at 100. Right, so you can do the same thing with other dimensions. So let's go. I'm going to rename this default by clicking in it and pulling away. I'm going to call it Alt -0. Okay, and let's double click on Alt 1 and say at Alt 1 I want the height of this to be 40. So inside the modify dimensions pop-up tool, you've also got those 3 little blocks which you can click on, and you can say this configuration, and just I always like to do that just to see that it's going to work. Say OK, and let's do one more. Let's just change this angle 15 degrees, and in this case I want it to be 10 degrees. Okay, so if I double click on the Alt 0, that's what I get, and if I double click on the Alt 1, it's changed the configuration. So I can have as many configurations as I want inside here. So this is a great way to change things. I mean, if you want to make minor changes, you want to test something that's 110 versus 100 millimeters and with slightly different angles, you can do that. And this applies to all your designs. Can't think of anything where it doesn't apply. It also applies to assemblies and to multi-body parts. You can have configurations upon configuration. So you could have like an assembly in which you have a configuration that uses different configurations from your part files. So I hope that's useful. I find it extremely useful. Instead of now designing 2 different parts and trying to find them, I can just go inside my configuration manager and just double click on it. In fact, let's just bring this through into see if we can do this quickly before we run out of time. How much time we've got left? Never know, it never tells me. 13:34, probably about 5 minutes. So let me save this, make assembly from part. Okay, now if I click on this part, you'll see that at the top here, I can specify the configuration, and it'll change it inside the part. And then I can go into the configurations inside here, and let's say, just for argument's sake, and let's see if I can bring in a part quickly. Yeah, that's a good idea. Let's bring in another version of that part, and let's mate this to this. And just flip that mate, and just basically do something like this. Let's say that's your configuration, and let's say in this configuration you want the 2 to be equal. So what I'd do is I'd go back to this one here, and I'd say give me the other Alt 0. Okay, so in this configuration they're equal, and in this configuration they're not equal. So that's the beauty of this. You can actually you can put things together using configurations in assembly and alter which of those configurations created in the parts that you want to use. Right, so I'm pretty sure we're going to run out of time fairly soon, and if we do, then we'll just continue at 2 o'clock. What have we got? 13:36. So we should have another 4 or 5 minutes. Let me see if I can close this. I'm not going to save it. Close that. And let's see if we can start on what I've done here. In fact, I'm going to close this. Oh, no, I'm not. I'm going to give you this part as a step file, and then I'm going to give you another part which looks like this. I'm going to give you this fascia, which I'll add some ribs into as well. So I'm going to give you those 2 parts, and I'm going to ask you to create an enclosure which looks like this. Okay, so you're going to give me that. Oh yeah, that's not doing it. You're going to give me the top part, this part which will slide inside it, and we'll deal with that when we come back, creating this jog feature, and then we'll also create some venting on the shroud. So that